Alright everybody, so oopsie, in today's lesson we're going to be looking at why a plus b squared does not equal a squared plus b squared, okay? And similarly, we're going to look for patterns so that we know how to factor things that look like, how do I want to write this? Things that look like this, for example. Okay, there's a special property about this, or something like x squared plus 4x plus 4, or x squared plus, I don't know, 16x plus 64. All of these are special, and I'll show you why, okay? But first, let's look at a plus b quantity squared, why it's not equal to a squared plus b squared. A plus b times a plus b. If we were to use a box to multiply these, right, we put a plus b, a plus b. A times a is a squared. A times b is ab. B times a is ab. And then b times b is b squared. So a plus b times a plus b is a squared plus 2ab plus b squared. This is different. A squared plus b squared is not the same thing. Oh god. A squared plus b squared is not the same thing as a squared plus 2ab plus b squared. It's missing the 2ab. So if you ever see something like x plus 3 squared, this does not equal x squared plus 9. Okay? In fact, let's see what it equals. X plus 3. This is actually the opposite of factoring. This is technically distributing, okay? X times x is x squared. X times 3 is 3x. X times 3 is 3x. 3 times 3 is 9. So this actually equals x squared plus 6x plus 9. What about x plus 4 squared? Well, it's going to have an x squared. And it's going to have a plus 16, right? Because of 4 times 4. So what do you think goes in the middle? Plus what x? It's going to be x plus 4, x plus 4, x squared, 4x, 4x, 16, 4x plus 4x is 8x. What about x plus 5? We know this is going to have an x squared. We know it's going to have a plus 25. But how many x's do you think we're going to have? If you said 10x, I kind of want you to tell me why. Just say it out loud. You'll have 10 seconds why. Okay, hopefully you said, well, you take this number here, I'll highlight the numbers, and you just double it. And if that's what you said, or if that's what you were thinking of, or if you were thinking about adding it to itself, you're absolutely right. We end up doubling it because you have 2 copies of those, right? Just like right here, you have a 3x and a 3x. That's just doubling it, 4x and a 4x. And the other, right, if we were to do it with the 5s, it'd be x plus 5, x plus 5. I didn't do the boxes, my bad. X squared, 25. This would be 5 times x, which is 5x, 5x. You essentially double it. So then the question is asked, well, let's do something really random. X squared plus 11. It's going to be x squared. And 11 times 11 is 121. But what's 11 plus 11? 22x. So what if we were to go backwards? What if I told you, hey, I have x squared plus, I don't know, 10x plus 25. Think about it. What's the whatever? What's the square root, or what's the second root of 25? 5, right? So it's going to be x plus 5 squared. But this only works if, once you figure out what the square root of 25 is, which is 5, you double it. And if it also equals 10, you can immediately go from this to that. Let's do another one. Maybe you don't know what the square root of 169 is. But what's half of 26? 13. And then you can check, is 13 times 13 equal to 169? If so, this equals x plus 13 squared. Let's do one more. X squared plus what number must go in the first box on the right so it's a complete square? So let's see, half of 14 is 7, right? And then 7 times 7 is 49. But what's gonna go here? A 7. Technically, this is a pre-version of the vertex form of a standard equation. But anywho, today's practice, or not today's, but whenever you get to this, is going to be just practicing going between, these perfect squares. In fact, let me just write this out. X plus a squared is just equal to x squared plus a squared plus